Okay, so this is continuation of the key to test 3. All right, so number 25, you're told that you have $16,000 and it says which investment yields the greater return over 4 years. And so you're given 6% compounded quarterly or 6.25% compounded continuously. All right, so if you just want to determine which yields the greatest investment, then basically just find out how much each account is worth at the end of 4 years. So how much did you have it in 4 years? You started with 16,000. How much do you have it in 4 years? And that will yield the greater return, and then that will determine which one's a greater return. So if you're if you're interested in being compounded quarterly, then you're going to use this formula here. You use the formula that has the natural exponential e if it says compounded continuously. All right, so let's look at the quarterly. So let's look at 6%. All right, so make sure you know how to use your calculator correctly, though. So we have A equals to the amount at the end of 4 years will be the principal, the initial amount, which is 16,000, times 1 plus the rate, 6%. Remember, you're going to rise the decimal, so that's 0.06, divided by n. N is the number of times being compounded per year for each year. So that's quarterly means every 3 months, so that's 4 times. Raised to the 4, n times t, so that's n is 4. So these should match up, times the number of years, which is 4. And so we're going to approximate this. And so let's see what we get. We get 16,000. So 16,000 times, in parentheses, 1 plus 0.06 divided by 4, close parentheses, raised to the, and then you could put open parentheses 4 times 4, close parentheses, but then that's just 16, so just say 16. And then equal, and you get $20,303.77. So at the end of 4 years, the 16,000 is going to end up being to this amount. All right, for the compounded continuously, so 6.25%. The amount at the end of 4 years will be P, which is 16,000, times E raised to the R is the rate. And remember, you got to write this as a decimal. Change percent to a decimal, so move it 2 places to the left. So that's 0.0625 times T, which is 4. All right, your calculator, you're going to say 16,000 times E, second, e to the x. It looks like this. And then you say 0.0625 times 4, close the parentheses, and then press equal, and you get this amount. So $20,544.41. And so at the end of 4 years, the one that yields the greater return will be the one that has the larger amount in it. So it'll be this one. So since the 6.25% has the greater amount at the end of 4 years, that's going to be our answer. So the answer is going to be 6%, 6.25% compounded continuously. Okay, number 26. So number 26, you want to graph this exponential function. And so you want to state the domain. So remember, the domain of an exponential function is all real numbers. Now the range will depend. Now the range is not real numbers. It depends on where the horizontal asymptote is and whether the graph is above or below it. All right. So basically, from here though, you can determine the range. So you know that the horizontal asymptote. If I go here, do that for next. The horizontal asymptote is this number right here. So that's, remember, it's a horizontal line, so you got to say y equals. You can't just say -5. You got to say y equals -5. So right here, if I go here and I draw the horizontal asymptote, remember, use the dotted line, I get that. And then before I even look at the range again, I can, if I want to, find the y-intercept. Remember, it always has a y-intercept. It may or may not have an x-intercept, but it will have a y-intercept because the domain's all real numbers. And in this domain is the x value 0. So to find the y-intercept, you let x equal 0, just like we did just like when we graphed the line earlier with the x and y intercepts. So if I let x equal 0, I get 1/2 to the 0, 1/2 to the 0 minus 5. 1/2 to the 0 is 1, so 1 minus 5 is a -4. So my y-intercept, and it says, it didn't say anything about ordered pairs, so you can just say -4. So that's here. So you'll notice that my graph, since this point's above the, since the y-intercept's above the horizontal, my graph's going to be above the horizontal, either going up or going down. We can discuss this in a little while. So the range, though, will be from -5 all the way to infinity. Now, since the graph never touches the horizontal asymptote, we're going to use a parentheses, not a bracket. So it'll be parentheses -5 to infinity. Okay, so remember, I just need to apply 3 points. I already found one. So also let's talk about this. So remember that if the base is an improper fraction, then my function's increasing. So we do something like this. Now that's assuming there's no reflection, so there's no negative out in front. If my base is a proper fraction, it's decreasing. So my graph's going to be decreasing here. So let's go ahead and use some negative numbers. So if x is, let's say, -1, I get 1/2 to the -1 power minus 5. And remember, to make this negative exponent positive, I just take the reciprocal. So the reciprocal 1/2 is 2, so you get 2 to the first minus 5. So it's 2 minus 5, which is a -3. So I get the point -1, -3. So that's right here. If x is, let's say, -2, I get 1/2 to the -2 power minus 5. So to make that exponent positive, I'm going to take the reciprocal of 1/2, which is 2. So I get 2 squared minus 5. So that's 4 minus 5, which is a -1. So I get -2, -1, which is here. And so then, remember, it goes, the graph goes towards the horizontal asymptote without touching it or crossing it, and then it goes through these points. So there's your graph, and notice that the range is from -5 all the way to infinity. That's what we said. All right, so that's number 26. All right, number 27, you're given this quadratic function, and notice that this is in vertex form. So remember, vertex form is f of x equal a times x minus h squared plus k, where the vertex is h comma k. So your vertex is 3, -4. Your axis symmetry is always the x coordinate of your vertex, but remember, it's a vertical line, so you got to say x equal 3. To find the y-intercept, you let x equal 0. And so when I let x equal 0, I get, in parentheses, 0 minus 3 squared minus 4. 0 minus 3 is a -3, and -3 squared is 9. 9 minus 4 is 5. So my y-intercept is 5. All right, so far I have this. I have the vertex is 3, -4, which is right here. My axis symmetry, let's go ahead and draw the axis symmetry. And then my y-intercept is 5. So once I know the y-intercept, then I know another point. So remember, this is 3 units to the left, so I'm going to have 3 units to the right. So here's another point, because it's got to be symmetrical about that axis symmetry. That's one of the reasons why we drew the axis symmetry. So remember, the domain of a quadratic function is all real numbers. Now the range, we can actually determine the range now. Since this is my vertex, the range will be, as you go, remember the range is your set of y coordinates. So as I go along the y-axis, I start touching the graph of this vertex, and that y coordinate's -4. So -4 all the way to infinity is your range, with bracket for -4. All right, now let's find the x-intercepts. To find the x-intercepts, you let y equals 0. So when you let y equals 0, remember that's f of x. So this expression here, this function, I'm going to set equal to 0. So you got x minus 3 squared minus 4 equals 0. X minus 3 squared minus 4 equals 0. So we had this in a previous test where to solve this kind of equation, this kind of quadratic equation, we're going to add 4 to both sides. And then we use the square root property. So I'm going to take the square root of both sides, don't forget that plus or minus. And so I get the square and the square root undo each other. So you get x minus 3 equals two things. A positive square root of 4, which is 2, and x minus 3 equals a negative square root of 4, which is a negative 2. And so you just solve each of these linear equations, add 3 to both sides, you get x to be 5. Add 3 to both sides, you get x to be 1. And you want to write this as an ordered pair. Each one is an ordered pair, so you get 5 comma 0, and then 1 comma 0. And so you plot those points. Here's 5, 0. Here's 1, 0. And then you just draw your graph. You're done. Okay. So that's number 27. And then finally, 28, you're given this quadratic function, except this time it's not written in vertex form, it's written in general form. And so to find the vertex, you use the vertex formula. So the vertex formula is this. So the x-coordinate's negative b divided by 2a. And to find the y-coordinate, whatever this is, you're going to find f of that. So it'll be f of negative b divided by 2a. So let's go and find the x-coordinate. Before we find the x-coordinate, let's determine what a, b, and c are. So a is the coefficient of x squared, so a is negative 1. B is the coefficient of x, so that's negative 8. And c is negative 9. All right, so I get the x-coordinate of my vertex will be negative b divided by 2a. So the opposite of b is a positive 8 divided by 2 times a is negative 1. So I get 8 divided by negative 2, which is a negative 4. So the x-coordinate of my vertex is negative 4. To find the y-coordinate of my vertex, I substitute negative 4 back into the function. So I got to find f of negative 4. So I get negative x squared, and x here is negative 4 squared, so it's got to look like this. The opposite of negative 4 squared, minus 8 times x, which is negative 4, and then minus 9. Negative 4 squared is 16, but this becomes a negative 16. So negative 16, and negative 8 times a negative 4 is a positive 32, and then minus 9. Negative 16 plus 32 is 16, and 16 minus 9 is 7. So my vertex is negative 4, 7. Okay, so is this a polynomial, rational, exponential, logarithmic? So remember this, all quadratic functions are polynomial functions. All right, to find the y-intercept, remember you let x equal 0. So when x is 0, I get negative, in parentheses, 0 squared, minus 8 times 0, and then minus 9. So that's 0, 0, minus 9. So you just get negative 9. All right, you want to determine the x-intercepts. To find the x-intercepts, you let y equal 0. So remember your f of x is y. So you set this equal to 0. So I get negative x squared minus 8x minus 9 equals 0. And then let's just use quadratic formula for this. You have a quadratic equation. So a is negative 1, b is negative 8, c is negative 9. So you had to find it earlier, so we're going to use it right here. So remember quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I get x equal the opposite of b, so b is negative 8, the opposite of negative 8 is 8, plus or minus the square root of b, negative 8 squared, and then minus 4 times A is negative 1, times C, which is negative 9, all divided by 2 times negative 1. So I get 8 plus or minus the square root of it, negative A squared, 64. A negative times a negative times a negative is a negative. 4 times 9 is 36, divided by negative 2. So I get 8 plus or minus the square root of, and that's 28 divided by negative 2. Now remember, you were told to approximate the x-intercepts to the nearest tenth. That's what you're asked to do. All right, so basically what's the first thing you're going to do is just rewrite this into two separate solutions. So I get 8 plus the square root of 28 divided by negative 2, and then 8 minus the square root of 28 divided by negative 2. So don't go ahead and don't simplify the square root of 28. Leave it like this, since you're just asked to approximate the x-intercepts. All right, now on your calculator, you got to say this. You have to say 8 plus the square root of 28, and then you say equal. So that's your numerator. But then you got divided by negative 2. Divide by negative 2, and you get this. So to the nearest tenth, this right here is going to be negative 6.6. Over here, approximating this, you're going to say 8, subtract the square root of 28, press equal, that's your numerator. You got to press equal first. You got to find the numerator first and then divide by negative 2. Otherwise, you're not going to get the same answer, the correct answer. Because if you, let me just go ahead and say this. So that's negative 1.4. If you had done this, if you had said 8 minus the square root of 28, close parentheses, and then say divide by negative 2, this is what you would have gotten. Now what you found here was this. The only thing being divided by negative 2 is this square root of 28. But remember, the whole thing has to be divided by negative 2. So that's why you have to say, once you put the numerator in your parentheses, once you put the numerator in your calculator, press equal, and then divide by negative 2. All right, so you want to write these as ordered pairs. So you're going to say negative 6.6 comma 0, and then negative 1.4 comma 0. All right, so that takes care of the key to test 3. So this part of the video covered problems 25 through 28.